suppose, I want to see what this term looks like. Oh, it's u2 over u2x, okay? But let's make it a little more explicit. Let's make one assumption, that the utility function is homothetic in time and goods of degree gamma. Gamma will be less than 1 or less than equal to 1 in a strong case, right? Because of concavity. Right? So basically, okay, so what do we mean? So if we have homothetic utility functions, it means that the property, if the function is homogeneous, let's say homogeneous of degree gamma, then we can write utility in period 2 is equal to 1 over gamma times u2x times x2 plus u2l times L2, right? With constant returns, gamma is 1, and this is simply the usual Euler adding up equation, right? Product of marginal productivities and quantities summed up is equal to the output or utility. When you have homogeneous functions of degree gamma, then you have to adjust for 1 over gamma. Okay? So if gamma, and that's where the difference between marginal and average utility comes in. If gamma is a half, then utility is double what you get from the marginal products effects alone. Right? It's twice as big. I'll give you some numbers on that later on. So now, if we look at this thing, divide this by u2x, 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 what do we get? Well, this drops out, so we get equal 1 over gamma times x2 plus L2, write that out here. Now what's this? Well, let's go back. That's why I wrote these equations down. If, let's say, it really does depend upon that assumption, but let's say in general that if we take this condition, we have, let's write it down, let's say beta u2x is equal to lambda over 1 plus r, right? And then we know from L2 that beta ul2 is equal to lambda over 1 plus r times w, right? So lambda over 1 plus r is equal to beta ul2 over w2, or betas cancel out, and that means that u2l over u2x, take x down here and bring this up, is equal to w2. That's general. So the marginal rate of substitution, let me put it in words. The marginal rate of substitution between goods and leisure in any period really only depends on the cost of time versus goods in that period. It doesn't depend on any discounting or anything else because you're doing everything within the same period. So that's what you're going to be looking at. Okay? Now why is that interesting? Well, because now we can say we can replace this thing by W2. And so now we have a very neat expression. Do a lot. So we have this very neat expression. What we're saying is that we look now, go back to our condition here, S prime, beta, and then this turns out to be 1 over gamma times x2 plus L2 W2, right, is going to be equal then G prime okay. So what we have done is say, well, this value, this benefit, we've now converted this benefit into neat expression, right? Well, because the term in brackets is your full consumption in period 2. It's a measure of your full consumption. Now, we take your actual consumption, we weight your leisure time by the wage rate, so we can add them up. They're all in goods units now, and it's your full consumption. So we say, well, the benefit is just full consumption adjusted for the difference between marginal and average utility. 1 over gamma. I mean, there's beta in there and all, etc. Right? That's what we have. No, I hope I didn't forget the beta. No, the beta's there. Okay? All right. And the cost, well, you didn't do anything on the cost side.